Hello everyone, my name is Andrey Devyatkin and today I'm gonna be talking about vault configuration as code via Terraform. And a side note, I usually sound way better than today, but well, a common cold, what you gonna do? There is a funny story or like funny game I meant that you could play with your kids. If you don't have a kids, you probably saw someone playing those games where you're supposed to be find a couple of differences between pictures. Could be quite entertaining, especially when it's happening on your production servers. And if it's happening during outage, or even worse, if it's happening during the intrusion that your intrusion detection system detected. So, and this talk is pretty much about how do you avoid of playing this game on your Vault production servers during those events. And few notes before we start. This presentation is mostly a collection of my experiences that I had installing a running Vault. I'm not pretending to be an expert, just sharing what worked and what didn't. There might be a better way of doing things that I'm showing you, and if you know the better way, please reach out and let's discuss. There will be technical details and references. There will be Terraform listings. And usually this presentation takes about 45 minutes, but I do have only 30, so I'm gonna skip through some of them. But slides will be available online, so you will be able to have all of that later on. About myself, I'm a technologist with more 10 years in the industry. Most of that time spent being a consultant, teaching different organizations of different sizes, industries about DevOps, continuous delivery. I'm quite good at fixing automation projects and organizations. I do run meetups and conferences. I speak often. I do trainings, so like Git, Jenkins, Docker, time to time, even Kubernetes for small teams, and have a number of certifications. So the tools that we're going to be using today is Terraform, which is a tool developed by HashiCorp to manage infrastructure as code. So basically call all those APIs available for you. A great tool. If you are new to it, it allows you to describe all your configuration as code in declarative way, which might be changing now with the advent of HCL2, but mostly declarative. It allows you to check the plan before you execute and see what you're about to create. There is also, it's a good way to manage automation. There is a lot of Terraform models that you can think about as libraries already created by other people that you could reuse. And the nice thing that this has providers for almost everything, and provider on Terraform world is adapter. Basically, the thing that knows APIs of the certain things that you want to automate, so like AWS, G Cloud, and a lot of other things. Vault adds secret management tools developed also by HashiCorp, which allows you to centrally manage secrets and reduce secret sprawl. It also allows you to move from static secrets being spread all over the organization to a short time dynamically created ones per use on demand. So then you have a much better auditing capabilities. And it allows you to do that across public clouds and private data centers. Plus signs, now you have a good traceability of who is using what, and you have leases of those secrets. It also provides you a break glass procedure of acting out if there is an intrusion in your infrastructure. So you know where the problem is, and you could revoke those credentials without breaking out everything around you, since every workload gets its own credentials. And where do you start with those tools? First of all, I would recommend collecting requirements and clarifying the context and infrastructure available that you're going to be running on. So where are you going to deploy Vault? Will you be running in VM? Will it be a container on some container orchestration system will be bare metal. How you gonna maintain it? Are you gonna patch those installation, or will you do immutable infrastructure and will just scratch everything, redeploy the newly built images or containers? How and who gonna be accessing them? Will it be public, which probably not the best idea? Will you be able to access it over VPN or service mesh, what have you? How you gonna unseal Vault, because Vault needs to be unsealed, so it has a master key to decrypted database. How do you get initial secrets, and what is the storage that you're gonna be using? And another thing is that since Vault is a place where you're gonna have your crown jewels, you actually want to have it locked down as much as possible. So the good idea is to have this box or container, whatever, is inaccessible from outside, which means that everything you might need out of it needs to stream to other services like logs, like telemetry. You need to stream the audit files, so you don't have to go there, so you can resolve all your questions without actually SSHing and jumping into the actual runtime that you are using. How are you gonna run it? Is it be multi-data center, or and also will you have one Vault instance cluster per environment, or will you have one Vault constellation to manage everything? So those are valid questions to ask, and I would suggest you go through them before you take any further step. But when you do answer those questions, look around. There are some best practices and templates. So for instance, there is official model for installing the Vault cluster on AWS. I believe there are several similar models for other cloud providers. I know Grantwork has a model. There is a Helm chart, and there is amazing resource from HashiCorp, which is learn.hashicorp.com. And there you can find a lot of guidelines about how you can go about running Vault. So I definitely recommend checking this out. There is a Vault production readiness checklist. As I said, it's a good idea to lock it. So, and those are some basic things that you really want to have. There are much more. Again, learn hashicorp.com, production hardening. So I strongly recommend that. And things like TLS termination. So you want your Vault to terminate TLS connection to it, because if you do terminate TLS connection on your load balancer, then the traffic between load balancer and Vault instance most probably will go over HTTP. So think about that. You don't want that to happen, because there might be someone in the middle sitting, which is very unlikely, but still possible. Then making sure that everything is encrypted everywhere, that you do unseal using, for instance, cloud KMS services, that you have a stripped down image that doesn't have any CVEs there, and so on and so on. Here's actually some good ideas. So you have audit on, which is, I believe, off by default, and you sync those audit files to remote storage like S3, and do integrity check for those files. As soon as you did that, you also configure the regional replication, and you stream and you replicate all those logs into the other account even. So anyone inside this account cannot access files there. In this way, you preventing anyone inside this account actually tampering those files. So you always have a golden copy that you can revert back if there is a problem. And you need to investigate what happened. Another good idea is to have MFA delete on archive buckets. So making sure that no one can delete without MFA, things like those. And this is something that I learned hard way. It's a good idea to split Vault deployment infrastructure and Vault configuration itself. And the difference here is by Vault deployment infrastructure, I mean like EC2 configuration or ECS cluster configuration, load balancers, basically everything that is needed to get Vault up and running. And Vault configuration is the specs that use Vault provider, Terraform Vault provider, where you're calling Vault APIs using Terraform. So those two, it's a good idea to split, because if you're doing the rolling rotation, it might happen so that Terraform just creates resources one after another, and since you are recreating something in an underlying infrastructure, at some point you might lose connectivity to Vault for a second or so, but it might happen that exactly at that time Terraform needs to call Vault API, and you left in a deadlock because Terraform will stop saying that there is a problem, I cannot reach Vault, and your infrastructure isn't done, and your Vault configuration is half applied, and you have to go back and fix it somehow. So that's why I recommend actually splitting them and applying them separately, making sure that they are not interfering with each other. Vault is up and running. What do you do next? So to start configuring Vault via Terraform, we need the following. You need to have a Vault URL exposed as a Vault other environment variable. You need to have a token, and when the Vault is just up and running, the only thing you got is a root token. And then when you're done with configuring authorization methods, you better delete root tokens. You better not store it because it's impossible to store root token if you don't have it. And there is a way to recreate them if you really need. So the good idea is to delete them as soon as you don't need them. This is how token looks like. If you never saw it, basically where do we have the token ID? It has certain policies. It says, and you can get idea why it was created, what was the authorization method, and so on and so on. And this is a slide I use as a brief introduction into Vault for the people who are not familiar. So you have auth methods that basically allows you to authenticate to Vault and get a token in exchange. Token will have policies attached to it, and those policies define what you could use this token for. So for instance, you can come from LDAP, get a token that allows you to use AWS secret engine to get temporary AWS access keys. So this is how it works. Or you could have like uprole, you get the token with a vault policy that allows you to access certain KV, and then you can read the values from there. I'm sorry. Carrying on. So in that sense, taking all of that into account, it makes sense to start on the left and configuring auth methods and policies. Boring. It's hard to define policies to figure out how exactly you need to slice access, but well, it is very important because this is something that enables you to use Vault without using root tokens. So you most probably will need to have more than one authorization policy. You will need something for humans to come in. You will need something for machines, maybe for applications. It's a good idea to use MFA where possible, but as far as I know right now, you will need Vault Enterprise for that. There are a lot of auth methods, and you see that's not even the end, and that's from the Vault website. So the way it works, you have auth role, you have a Vault role, and that defines what policy will be assigned to token you get. And in LDAP case, you have LDAP backend group, and that's Vault term, and that will get you a token with a policy. And it's a good idea to use something like LDAP because it leverages existing IAM setup, it's the case credentials, validations, and it's mostly used by humans. And this is how you define that in the Terraform. The good thing to pass a password as a variable to make sure that you don't store it in source code. And there is a comes chicken and egg question, like you could technically fetch this password from the Vault, but you don't have Vault at the moment. So how do you go about that? And this is something that everyone have to answer for themselves. This how do you do this bootstrapping procedure? This is a role that basically says everyone who comes with a valid LDAP credentials and is part of the DBA LDAP group should receive policy DBA on their token. And you don't really have to name policies after the group names, but it makes a lot of sense. It just simplifies things a lot because person who is an LDAP TBA group, it knows that he will get a TBA policy and not something else. So it's just a little bit more logical. And this is how policy looks like. This is just example policy, not related to DBA or anything, but basically Vault is API based, so it's HTTP path based, and you say you could access secret and those capabilities that you could do there, and description of why it's there at all. And the funny thing is that you will need to have a policies to manage policies. With root token, you can do whatever, but when the root token is gone, I really hope you do that. Then you will need to have a policy that you can get, so you can elevate your permissions to get this policy to manage other policies. And that's why I'm saying, like, figuring out policies is complicated. Vault is using deny by default, so if something is not allowed explicitly, it's denied. And as I said, you don't have too much LDAP group names, but it's just easier for everyone involved. A member of multiple groups gets multiple policies, which is super handy. Things to consider. There are certain options that you can apply when you're configuring the backend. So you could specify that the token is valid for 8 hours only, and usually that's enough, because when the person goes home, token gets revoked. Everything that was accessed using this token, all like, for instance, temporary AWS keys that was created using that token got revoked as well. So it's in the end of the day, you have a really nice way of cleaning up, and then during the night you can check what tokens are active and should they be active. A little bit of intrusion detection things, you know. Uproll, if you really have to. This one is mostly, it's basically a username and a password, mostly used for CIs, which it resides outside of your infrastructure, like for instance, Circle CI, and you're not using on-prem workers. It's not really a good way to audit access, because anyone can copy those and get the token. So I recommend avoiding those if you have a choice. This is how you do that via Terraform. You define the authorization backend, then you define the role, saying that that's a test role, and it will get those policies. Everyone who authorizes with this role will get those policies. And then you could run this command to say secret ID, and that will give you a secret ID, which is a login. And then, yeah, so your role ID you get, and then you get the role ID. Oh, sorry, so secret ID is a password, and role ID is your login, and you use those two values to authorize in Vault. But what you could do also, you could actually read it this way and then store it in a KV, and then read it from KV. In this way, you could use Terraform to tie in those, and they will be recreated next time you run it. And you don't have to pull them from the state. They will be saved to KV, so you can get them and provide it to CI engine if needed. This is quite nice for things. So it's Cloud IAM in this case. Vault will leverage another system that provides some kind of identity to verify that this entity that has this identity can get in and get a token. So for instance, with AWS IAM, you would leverage your instance profile if you're running on EC2, or if you're running on EKS, then you get instance profile for your pods there. And what it says is, if you have principals with those ARNs coming in, then it's fine to authorize them, and that's the role. So this role, anyone with those ARNs can authorize that they will get a token that is valid for 60 seconds, and it will get this policy. But it's not that easy, because Vault needs means to look into AWS and validate what's being provided, because you're going to send a signed request to Vault, and Vault needs to be able to check that everything you sent in is valid. And that's why you have to create a user and access key and the policy for Vault, and you will provide those keys to Vault to go in and check that. So that's needed. That's a policy, and that's a house backend client. So basically, it's the things that will go into AWS and check your request. For Kubernetes, you could use service accounts. And actually, last year on HashiTalks, I did the whole presentation about that. How do you do that on Kubernetes? So if you're interested, you can check it out on the HashiCorp YouTube channel. So now you have a token. What do you do next? Now you start to configure secret engines, and you can get dynamic credentials or static one from KVs, and which is nice because then the dynamic credentials have a limited lifetime, and it prevents sharing because they're going to be revoked eventually. So there is no good reason to share them. And as I said, you have a better means of auditing and break glass procedure if something goes terribly wrong. So KV is basically what it is. It's key value store, where you store your static secrets, something that you cannot really generate. And like, for instance, SSL certificate that you get from your CA, right? Which just might be not in your company and you're not created a dynamic, like validated SSL certificate. And there is a good idea to actually split KV. So you're going to have a KV, which is humans initiated, where developers, operators can put stuff, and that might have a little bit of messy structure because it's created by people. But then using Terraform, you can also create machine readable and initiated storage for static secrets. And when you're running Terraform, you will use Terraform to get the stuff from those created by humans and maybe look up something in your cloud provider, then just dump it in a predictable structure for machines to read, for instance, for your applications, because then you guarantee that this is always the same and no one is coming in there and messing by hands. This is how you would get the AWS credentials. Again, you need to have AWS users that Vault gonna use to go in and provision the either session credentials for you or keys. There are few ways how you can configure that. So you create user, you create the key, you create the policy. That's what you need to attach to the policy, and there is a great documentation about that. Then you would create a secret backend, which basically receives AWS configuration, and you also set up default list ETL, which basically means for how long your credentials going to live, and that's 8 hours, I believe, and that's close to a couple of days, probably. Right, so that's a role, and this is how you configure that. As I said, I'm scrolling through those quite quickly to make sure we're getting into the time, and then you obviously need to be able to assume the role. So, and then you call Vault like this, and it gets you a temporary AWS key, AWS secret key, and security token. And in this case, it was configured so that they are valid only for 60 minutes, but you have a chance to renew it using this lease IDs if you want to use it longer, because you can see here lease is renewable. And there is actually great ways that you could get those temporary credentials from Vault and then generate signed URL. And then you don't need SSO, you don't need static credentials in AWS for users, which is quite amazing. That's a link how you can do it. I don't take credit for this. I got this idea from attending the talk on HashiCorp EU last year, and the talk name was Growing Vault at Hootsuite, which I recommended a lot. A lot of good ideas in there, so check it out. So database creates, you can get temporary database credentials, which sounds great, but it is complicated to set up. Since there is a creation and revocation statement that you need to define by yourself. And if it's not done right, Vault won't be able to revoke credentials. For instance, if you create something by temporary credentials, then you have to, when you're revoking them, you have to transfer ownership to something else. And if it's not done properly, then Vault's stuck and it's just not possible to remove the credentials, and you have to go in and fix it. If you have a possibility to use something like RDS IAM mouse, where you can use your temporary AWS credentials to authenticate to Postgres, I would suggest doing that, because, well, this is quite complicated, I would say, unless you have experienced DBA around you. The secrets rotation, which is something that you cannot really do now via Terraform, at least for the database credentials, because you only want Vault to know the database credentials. So I actually wrote a little bit of bash script that goes around, checks what database secret engine is configured, and then calls Vault API to rotate root credentials that used to create those temporary credentials. Because with databases, as the same as with AWS, you have to provide the root credentials for the database, so Vault can use those credentials to go in and issue temporary credentials for you to use. So there should be some credentials at the beginning. And when you're calling this API, you actually ensuring that the initial password that you provided is not longer valid, because Vault is going to rotate, and then Vault is the only entity that knows the password. You might ask yourself, how do I get myself out of situation if I really need that password? Well, you still have AWS console, so you can still go in the console and reset the password if you really, really need. For AWS root keys, you could do Terraform taint, and then Terraform apply, and Terraform will automatically recreate stuff. So there is an API for Vault that you could use to rotate credentials, but then Terraform get confused because Terraform knows that he created the key, but then Vault deletes the key. And when you run Terraform will try to create new key, but when Vault deletes the key, it creates a new key. So you have actually two keys assigned to the same user. Next time you do that, you will end up with 3 keys, which is impossible by default. And yeah, it gets confusing. And you want to rotate those credentials on a regular basis just to make sure that they're not stolen, because all of them are available in Terraform state that you have to encrypt. Otherwise, someone can get hands on those. Some unexpected findings. KV state issue. Yeah. So when you define a KV in Vault and you use Terraform to read it using data resource like this, it works fine first time. But if you go into Vault, for instance, in UI and add additional values, for some reason, Terraform will not try to reread it because it's already have it in the state. So the way out of it is to say Terraform state rm and then pass to the data store, the data source. So for instance, data dot file generic secret dot this thingy, and that will force Terraform to reread it. I couldn't find any reportings about that, but I saw developers bumping into that consistently. I bumped into that myself a couple of times. So something isn't right. And I haven't seen it for months. I haven't bumped it for the months. Maybe it's solved. I don't know. But if you get in the situation like this, then you know what it is. My duty is to warn you and save a little bit of time, because first time I spent a lot of time trying to figure out what's going on. The final thought. Vault introduction is a journey, so start small, start onboarding developers slowly, and configure things as you need. Don't try to configure everything right from the beginning. Start with one house method, develop this use case, find the use case that is most critical for you. For instance, making sure that databases has different credentials and developers get read-only credentials when they need to access database, something like that. And then implement that use case. And then when that is done, when that is working, expand, implement next use case, and slowly moving over, because Vault can do so much good for you. Doing it as code, I believe, is the most safe way available for you, because configuring all of that by hands is building up a path to trouble later down the road. Reuse and share when and where possible. I mean, there are terrific open source models, there are blog posts, but I don't think it's enough. I think we need to post out more and discuss it more, because the product is still quite new. The ways of working are quite new, and we need to build the best practices. We need to share how we do it, because the more we share, the more we learn from each other, the more secure all of us gets, right? In our working with our respective customers or employers. So the sharing is good in this case. And as you saw, there are still some places where a little bit of glue needed. I believe the HashiCorp went a long way comparing to 2 years ago, because like in 2018, nothing of that was possible. I mean, the Terraform provider for Vault was almost non-existing. People still were calling like Vault API or using Vault CLI to configure things. But now you can do almost everything you want using Terraform provider, which is amazing. I mean, it's a great work done by the provider team. So my applause to them, and my words of appreciation to them. And with that, I would be closing down.